Hello, hello, hello. Welcome back to this beautiful Thursday edition of Squirrel Tries to Teach Advanced Proofs, and we'll see how that works. She is napping, so I'm going to take over, see what happens. We're going to start with what we should have done for homework, or at least what you should have tried by yourself. I'm going to do the nice statement reason chart, like we always do, and we're going to start with what we want. We want A, E, and EC. Notice I have bubbled those, not marked them, bubbled them. You bubble the things you want. So we want A, E, and EC. We do not have A, E, and EC. We need to find A, E, and EC, probably by dealing with some of the triangles. So, first given, AB equals BC, given, AB equals BC. Next given is AC perpendicular to DB. Of course, that is a vocabulary term, so our next step needs to be definition of perpendicular. Now, Squirrel and I got into a big fight yesterday because of the definition of perpendicular. She mixed it up and she said it was bisect. That's not true. That is the symbol for perpendicular. That upside down T is a symbol for perpendicular. Perpendicular means 90-degree angle somewhere. It's a very different from bisect. Bisect means that there are two equal pieces somewhere. Definition of perpendicular means 90-degree angle somewhere. So we're going to look at AC and BD, and we're going to take a look, and there should be nice right angles all around there. Now, I could list out all of those right angles, but at this point, it's looking like this triangle and this triangle are the ones that they want us to prove. Because it's only those two triangles, I'm going to just be listing those angles. Could I list all of them? Yes. Would it be annoying and boring? Yes. So we're going to do measure angle AEB and measure angle CEB. They both equal 90 degrees. Okay, so we got a pair of sides, we got a pair of angles. Moving on, we've got a nice reflexive side in there, really tiny. EB equals EB by reflexive. And at that point, we can prove something by HL. Very excited we can prove by HL. I can prove this guy. We've got angle side side. Notice my angle is not between my two sides. It's not SAS. It's ASS. Can't do ASS, but we can do HL because of that right angle there. So we need to say triangle, and be very careful how you phrase this triangle. I'm going to go from A, E, and B. So A, E, B is congruent to triangle. Now I started with A. The angle that matches A is C. E, the angle that matches E is going to be E. And the angle that matches B is going to be B. Okay, notice, for those of you paying attention, I did leave a gap. Always leave a gap before you do HL, because you need to do that step. Now, some of you have learned to just do that step automatically. Some of you still writing it in after you do HL. Just make sure it gets there. Don't care which order, just make sure that it gets there and it's above HL. Right above HL, you need to say 90-degree angles. And you have to tell me that those two triangles are right triangles. Otherwise, we can't use hypotenuse leg. Okay, so now we've got those two triangles congruent. I got the pink triangle, I got the blue triangle, which means I can finish this sucker up and say AE must equal EC because corresponding parts in congruent triangles are congruent. And that's how we do number 5. So that's what we should have done. I want you to try to do that by yourselves, see if you could handle it, because we're about to build on that, and we're going to build on that substantially. Before we start building on this corresponding parts and congruent triangles are congruent, I want to do a few more examples, because the notes for the next one, corresponding properties and congruent triangles part 2, that gets scary. So before we go to scary, I'm going to do some more of these. We're going to do question number 4. Okay. Statement reason. First one, BC is parallel to AD. We have not had a parallel in a very long time. We have not done that whole parallel thing in a very, very long time. So I've got AD and I've got BC. We've got transversal right here. Notice we have to go from orange to orange when we list out our angles. And we've got parallel. Parallel does not say definition of parallel. We need to say parallel lines form congruent something on the transversal. Okay. And remember, we're going from orange to orange. So in my first blue triangle, the orange to orange is going to be right there at D. So if I go orange to orange, it's going to be right here at D. So measure angle ADE equals orange to orange in my other triangle is going to be up here. So measure angle EBC. Okay, so we got parallel lines, we got a nice pair of angles going on here. Now I've got E is the midpoint of BD. Okay, E is midpoint BD. That's my given. And of course, we've got midpoint, so the next thing that has to go in is definition of midpoint. Notice, is there something that I forgot before I started to do the second given? Because I've seen some people doing that. I've seen some people writing this out, leaving this here blank, and then just going on with the rest of the proof. That is not okay. Calm down. You need to relax. Parallel lines form congruent something on the transversal. That is a blank you need to be filling in. Just a thing out there. If I take a look, this is inside the parallel lines, and if I notice, both of my triangles are inside the parallel lines. Since both of them are inside the parallel lines, it would be alternate interior angles. Just putting that out there. Don't forget that. Some of you have been. It's been scary. Okay, so on to our next given. Now I can move on to the next given. We've got the given. We got the definition of midpoint. Okay, definition of midpoint of BD. So BD is our transversal. If I chop BD into a midpoint, E means it has to be exactly in the middle, which means this side is exactly the same as that side. So EB is now equal to DE. Exactly in the middle. Okay, now, some of you are going in different directions at this point. Some of you look at this and say, oh my goodness, we only did one transversal. We can do another transversal over here. And yes, you could do another transversal over here. Some of you are looking at this picture and saying, wait a second, there's vertical angles. Hold up, wait a minute, vertical angles. Vertical angles are very important to me. Well, let's do some vertical angles. It doesn't really matter which way you go. I'm going to go with the vertical angles because vertical angles are near and dear to my heart, but you could do a second transversal here, in which case the angles at A and C would also be congruent by alternate interior angles. So you could do another round of that if you wanted to. I prefer to go for these vertical angles right here. So measure angle AED equals measure angle BEC by vertical angles are congruent. Okay, so we can now prove that the two triangles are congruent. So we're going to go through, we're going to prove that the two triangles are congruent. I've got triangle BEC. BEC is congruent to triangle. Okay, B matches with D because they're both in green. And then E matches with E because they're vertical angles. And then C matches with A. And I proved it by side, nope, angle, side, angle. Notice S is trapped between my two angles. Because my side is trapped between my two angles, we've got angle, side, angle. Now, we're all well and good there, but notice they're doing something different here. They're not saying prove that this is equal to this or prove that that's congruent to that. It's saying prove E is the midpoint of AC. Our mission is to look at AC and figure out what's happening there. Well, I know that AE and EC are equal. And I know that because they're now in those two triangles. We've got the pink triangle right here. We've got the blue triangle right here. We have locked those into place. Those are now congruent. At which point I can say that AE and EC have to be equal. Corresponding parts in congruent triangles are congruent. Undo. Incongruent triangles are congruent. So we got corresponding parts in congruent triangles are congruent. And then what I want to do is we're going to go backwards through the definition of midpoint. I can say then E is midpoint of BD. Why? What does midpoint of BD mean? If E is the midpoint of BD, that means what? What do we say for the definition of midpoint? That it's chopped into two equal pieces. And we just proved that that line is chopped into two equal pieces. So I can say E is the midpoint of BD because AC, E is the midpoint of AC because AC is chopped into two equal pieces by E, also known as definition of midpoint. Yeah, that one's crazy. In this case, we're going backwards. We've got definition of midpoint, and the midpoint is going up the proof instead of down the proof. That's what's weird about number 4. That's why I like number 4. Because midpoint goes up afterwards. Most of the time we won't be dealing with prove that it's a midpoint, but I want to show you what happens if we get something like that. Most of the time it will just be proving like two sides or two angles are congruent. Let's do, sure, number 6 sounds like fun. Number 6, statement reason. AD is a perpendicular bisector of BC. Okay. AD is perpendicular bisector of BC. Now notice AD is not being bisected. It's not being perpendicular. Nothing is happening with AD. BC is the guy of interest right here. And notice we've used perpendicular. So the first thing that we need to do is definition of perpendicular. Perpendicular gives us 90 degrees. I won that battle with Squirrel. Definition of perpendicular means 90-degree angle somewhere. Okay, so it's going to be on BC somewhere, and it's going to be where AD hits BC. Okay, so there's a lot of right angles in there. I want to prove AB, so that's this, is congruent to AC, is this. Okay, if I want to prove those two sides, I'm probably not going to use the top triangle and the bottom triangle. I'm probably going to want to prove this triangle and this triangle. So I'm going to stick to just those angles. So I'm going to say AEC and measure angle AEB. And we're going to just look at those two angles right in there. That's definition of perpendicular. You need to do a separate thing for bisector. So we've got definition of perpendicular. Next thing we have to do, definition of bisect. Okay, bisect means to chop into two equal pieces. So BC is being bisected. If BC is being bisected, that means BC is being chopped into two equal pieces. So we're chopping BC into two equal pieces. That means CE is equal to EB. Okay, so we got definition of perpendicular and definition of bisect, which means we have completely destroyed that given. That given gave us a lot of stuff. It gave us a pair of angles and a pair of sides, which is actually very helpful. If we take a look at the two triangles I've marked, that means all I need is this reflexive side. So AE equals AE by reflexive. And then I can prove my two triangles congruent. So two triangles congruent by side, angle, side. Notice we do have a right angle there, but we're not doing HL. These are our hypotenuses. We don't have our hypotenuses. We want our hypotenuses. We do not have AC and AB. We want AC and AB. So we're going to be doing side, angle, side because I've got the green, the blue, and the purple. So I'm going to start with triangle AEC. It's congruent to triangle. Okay, angle A matches angle A, angle E matches angle E, and angle C equals measure angle B. Okay, now I have proven those two triangles are congruent. Once I've proven that those two triangles are congruent, I can say AB is equal to AC because corresponding parts in congruent triangles are congruent. That's how we do CPCTC. That's the basic. Frequently, they're going to want you to just find one little piece of it, like this guy, just one pair of sides that we don't have, but you can prove triangles, and by proving triangles, you can get those sides. Sometimes it's proving angles, like this guy. This guy we proved two triangles are congruent so that we could get a pair of angles. This guy was another pair of sides. This guy was a pair of sides, but just remember, it hid the fact that they wanted a pair of sides. It asked prove that E is the midpoint of AC. Well, proving E is the midpoint of AC means prove A is chopped into two equal pieces. So it wanted you to prove that there were two equal pieces, that that side had fractured into two equal pieces. But it didn't come out and tell you that. That's one of the most annoying ones that they can give you. That's just mean. Very cruel, very cruel. All right, so let's take a look at advanced, what corresponding properties in congruent triangles part 2 looks like, because this can be a little bit more traumatizing. All right, so I need to write out our givens. We are given that AB equals BC and that BE bisects angle ABC. We want to prove triangle ADE is congruent to triangle CDE. Okay, so let's take a look at what I want to prove. I want to prove ADE. So ADE is ADE. Got a nice triangle up here. And CDE. CDE is this triangle right here. Okay, so we've got two beautiful triangles that we want to prove. So far, so good. Nothing has changed. This is looking very similar to a proof that we would normally do. So we're going to do our statement reason chart, like always. And we're going to start with our first given. Our first given is AB equals BC given. AB equals BC given. At this point, you might notice that there's a problem. At this point, you might start noticing that the givens that we are given are not in the triangles that we want. And that is the key to this. Let's take a look at our next given. BE bisects angle ABC. So we are bisecting angle ABC. So angle ABC is this angle right here. It's being bisected, chopped into two equal angles. So I got two equal angles there. So that's a given. Bisects means definition of bisect. And we need to do measure angle CBE equals measure angle ABE. Okay. So we're done with our givens, and none of our givens are in the correct triangles. However, if you notice, they are in a pair of triangles. They are in a pair of triangles. This guy over here is a beautiful triangle, and so is this guy over here. They are two decent triangles. If we don't have givens in the original triangles, let's make givens in the triangles that we have. Let's actually try and prove the triangles that we have. If we want to prove the green and the purple triangles down here, it's actually going to be fairly easy because all we need is BE equals BE reflexive. So BE equals BE reflexive. Okay, so that means triangle, green triangle. So ABE is congruent to triangle, purple triangle. A matches with C, B matches with B, and E matches with E. By side, angle, side, because my angle B is trapped between my two sides that I have. Okay. So I've got the green and I've got the purple triangle. I need to get the pink and the blue triangle. So let's see if I can use corresponding parts incongruent triangles are congruent. Are there any places where the green and the purple can help us with the blue and the pink? Well, if you take a look, the green and the pink overlap on this side, and the purple and the blue overlap on this side. So based on this, I can say AE equals EC. Okay, now I finally have a pair of sides in the pink and the blue triangles. We finally have a pair of sides in these two triangles. That's very exciting. Do we have anything else? Not really. But if we take a look, we've got this angle right in here. Let's take a look at E. This angle and this angle, 1 and 2, we have because they're in the pink and the purple triangles. Using angle 1 and 2, we might be able to get this angle and that angle. If I were to mark those angles in the pink and the purple triangles, I might be able to get into those triangles, which means it's linear pair time. This is measure angle 1 equals measure angle 2, because that's in the pink and the purple triangles. So the corresponding parts in congruent triangles are congruent gave us two different things. It gave us the purple side, and it gave us the black angles inside the purple and the green triangles. Now I need to get them in the pink and the blue triangles. So in order to get them in the pink and the blue triangles, we're going to have to start again and linear pair this. So measure angle 1 matches with, on the line, measure angle 3. And measure angle 2 matches with measure angle 4. Okay, linear pairs. Then we have two forms of substitution that we need to get. So we're going to do some substitution in here. Substitution. Okay, going back up here, we know that 1 and 2 are equal. So they can either both be 1 or both be 2. So let's change them both to 1. Plus measure angle 3 equals plus measure angle 4. That's our second substitution. And then I got measure angle 3 equals measure angle 4 by subtraction, because I just killed off that measure angle 1. Okay, so now I've got measure angle 3 and measure angle 4. Okay, we've got a pair of sides, and now we have a pair of angles in the pink and blue triangles. And if we look very closely, we have a nice reflexive side there. DE equals DE by reflexive. And we've got side angle side to finish this out. So side angle side to get triangle ADE congruent to triangle CDE. And that is how we prove two triangles are congruent when we have no givens anywhere near those two triangles. I know, it looks painful, but hey, we've made it to 14 steps. That is super exciting. That is a beautiful, gorgeous, long proof that we can be very happy with. And pretty much what happened was I took one proof right here. This proof is something that we would normally do to get the green and the purple together. So we got the green and the purple together, and then we did another proof to get the pink and the blue together. All I've done is I've taken those two proofs and merged them together. I've taken one proof and used the information that I got from that proof to help me with a second proof. I know. Looks insane. Looks pretty insane. But it's also adorable. Your mission for today, I want you to try and look at which one? Let's try and look at number 1. I want you to try and do number 1. See what you can do with number 1. It's very similar to the one that we just did. So take a look at it, see what you can do. If you have questions, be sure to message me. Thank you very much and have a wonderful day.